Hi everybody, this is Gigi from Kauai Community College. In this video, we will talk about the definite integral. Okay, so what is a definite integral? Before we go there, I want to talk about the net area, or some books will call this signed area, which means the area with a sign, so it could be negative, using the Riemann sum. So how do we interpret Riemann sums when the function is negative at some or at all points in an interval AB? That's what the question is at this point. Okay, so let's put some example up here. Evaluate and interpret the left-hand sum of the function f of x equal to 1 minus x squared on the interval from 0 to 2 with n equals 10. So as we can see, that the function f of x is an upside down parabola for the interval of interest from 0 to 1, from 0 to 2. Part of the function is below the x-axis and part of it is above, right? So the net area would be positive contribution plus negative contribution, and depends on which is bigger, your net area may be positive or negative. Okay, so if n is equal to 10, as we are saying here, then the delta x, meaning the base of the rectangle that we are going to partition, we're going to divide this up into 10 equal parts, right? So the length, or we would say delta x, will equal to the delta x will equal to the length here, which would be 1, 2, right? 2 minus 0 over 10, and that is going to be 1 over 5. Okay, so that is what we just had written. Okay, so each one of these partition will be 1/5. So we're going to go ahead and draw in our rectangular strips. How many of them? There will be 10. So that being 1 right there. 1, 2, 3, 4, 5. And we're looking at the left-hand sum. So we're going to start right here at f of 1 out like that. Okay, so that's the area we are looking to estimate. So each one of these have a base of 1/5, right? And the height being the function value, and the first one being f of 1, the second one being f of 0, and the second one being 0.2, f of 0.2, and then the third one would be f of 0.4, and so on. So each one of these, and let's just look at the definition of what a Riemann sum is. This represents the base of the rectangle, and this function value is the height of the rectangular strip. And I put height in quotation because the function value could possibly be negative. Okay, and so when you sum them all up from 1 to 10, then you will get what we call net area, and that is what the Riemann sum is. So in this case, I would write 1.5 in the front because each one of these will be multiplied by 1.5, right? And so that's the base, and all of these behind here would be the height, And we can see that the green part right there is our positive contribution, and the red part would be our negative contribution to the net area. When we do the calculation, the green part is 1.9, the red part is contribution is negative 2.6, right? All of that really being multiplied by 1.5 being the height. Okay, so then what we have when we take the difference, that would be our left-hand sum, or we call that the net area. Okay, so that is what we mean by net area or the Riemann sum. Riemann sum can possibly be negative if the sum of the area is below the x-axis. Okay, so we really have to be careful of what the question is asking. Is it asking for the net area, or is it asking for the area formed by the curve? And that's sort of the difference between the two. So we were interested in continuing on from the last video. We were interested in how we can get this estimation to be more accurate, right? So as you can see here in this picture, when n is 6, meaning we have 6 rectangular strips, we can see that it's not a very good estimate because there's still like empty spaces in between, right? There's empty spaces here, empty spaces here, or there's like stuff that we have counted there that was not supposed to be there, right? So now let's say if we have 40 subintervals, you can see in this picture that the error part is getting smaller and smaller for us to be able to recognize. And if we go to as far as even 75 intervals, the picture will show that, look, the error is very, very, very small. Well, what if n is infinitely many? If n is infinitely many, delta x is approaching 0, or we say that strips is very, 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 very thin, then we can get a very accurate area. I mean, it would just be so good that we can be happy with it being the actual area, net area of the curve. Okay, so that is the idea of what we call a definite integral. So I'm going to go ahead and define what a definite integral is. It's basically the sum of all of the rectangular strips. It's the net area when n is approaching infinity, when there are so many, infinitely many partitions. So the net area become what we call a definite integral. And we will say that the function f is integrable over the interval from a to b. So there is a definition of what an integral is. Okay, now the next video we are going to figure out how to evaluate that interval, because if we can, then we can now find the area of all of these funny looking shapes. Okay, so that's where we're heading. But now let's just take a look and see if we really understand the wording here. The area formed by the curve and the x-axis, that area being just 3, 1, 2, 5, and that would be 11 square units. Okay. However, if someone were to ask you, what is the integral from a to e, right? The integral from a to e, from a to e, we are asking you for the net area, and some of it is below the x-axis. So these are your negative contribution, and then those are your positive contribution, so that the net area, or we say the integral from a to e, is going to be 3 minus 1 plus 2 minus 5, which is -1. So that's the difference between calculating the area formed by the curve and the integral. So really watch out for the wording, what the question is asking. The integral can be negative, whereas the area is not. And we know area is not negative, right? So some properties when we are dealing with integrals, so these have been proven. The integral from a to a, meaning you haven't gone anywhere, so really there isn't a net area. So then the integral from a to a is 0. And then the integral from a to b, the integral from a to b, when you switch the limits of integration, that's what those are called, limits of integration. When you switch, you will get the opposite answer, okay? And then the integral from a to b, the integral of a sum is the sum of the integrals, just like we have figure in terms of limit, right? Limit of a sum is the sum of the limit. And the reason for that is because we had just defined a definite integral using limit as n goes to infinity. So limit law should apply, which means that the integral from a to b of a constant times a function, we could pull the constant out. So that would be equal to c times the integral, just like the limit law, okay? And then the integral from a to b is the same as the integral from a to some point in between a and b, and then you continue on plus the integral from p to b, so forth, okay? So let's give you some examples so you can see how these properties, these rules work. So suppose that the integral from 0 to 5 of f of x dx is 3, and the integral from 0 to 7 of f of x dx is -10. Let's see what this is. The integral from 0 to 7 of 3 f of x dx, that is rule number 4, right? So that is going to be 3 multiplied by -10, and that is -30. Okay, next, the integral from 5 to 7. Well, we say that the integral here, that would be property number 5. We say the integral from 0, hold on just 1 second, I would say the integral from 0 to 7 of f of x dx is equal to the integral from 0 to 5 of f of x dx plus the integral from 5 to 7 of f of x dx. That's what rule number 5 said. And this is -10. This is 3. Therefore, this thing that we are looking for, let's call that some value. Let's call that smiley face. So then smiley face is going to be -10 minus 3, and that is -13. So that's what that is. Okay, and that is rule number 5. Okay, next, if we were looking for the integral from 5 to 0, well, that is going to be the opposite of the integral from 0 to 5 of -5 f of x dx. So negative times a negative is going to be a positive, and rule number 4 said I can go ahead and pull out the constant. So that would be 5 multiplied by the integral from 0 to 5, and that would be 3. So this would be 15. Okay, so make sure you apply the rules properly. Don't make up your own, and if you do, you better prove it. Next, we are asking for the integral from 0 to 7 of the absolute value of f of x dx. Well, some of you might think, well, isn't that just absolute value of 10, of negative 10? And the answer is no. Okay, we cannot determine this. Cannot be determined. And I want you to go ahead and give it some thought. Why? I want you to think about why this cannot be determined. If you can answer that, you really understood the concept of integrals.